Number 6 from the homework. Find the area of a regular hexagon inscribed. So we're going to cross that out and write inside a circle with a radius of 6√3, and my computer's lagging a lot. Okay, so we have a hexagon inside a circle. So if you want to draw your circle first, you can. And then you can draw 1, 2, 3, 4, 5, 6 dots. Connect the dots. Nice. Pretend it's gorgeous. Okay, so the circle, it's always the circle, by the way. You're like, who does the radius belong to? It's always the circle's radius. The circle has a radius of 6√3. So you have to decide, does the radius equal the radius, or does the radius equal the apothem? And in this example, we want to draw a radius that will touch both our circle and our polygon. So we would draw this radius right here, 6√3, and then we would draw our apothem. A lot of times what I do is draw a quick sketch of what's going on, but then I know all I really need from that picture is my right triangle made up of my apothem and my radius and half of my side. And so I kind of redraw that a lot bigger so I don't get confused and it's not too messy. 60/30, because a hexagon is a special case. Don't put 60/30 in a pentagon. Don't put 30/60/90 in an octagon. But a hexagon is a special case. So if we have the rule x√3, 2x, 6√3 is the hypotenuse. It's across from 90. So 6√3 is the 2x. I want to undo multiplying by 2. The way that I do that is divide by 2. So across from 30 is 3√3. And across from 60 is x√3. You can put that in your calculator if you're scared to multiply radicals and do it wrong. But it is 3 times 3, which is 9. We are ready to go to our formula. Apothem times, okay, perimeter. We need to be careful. The whole side is not 3√3. The whole side is 6√3. And there's 6 sides. So this is the perimeter. Apothem times perimeter divided by 2. So you would do 9 times 36 in your calculator divided by 2. 9 times 36 divided by 2. Okay, I thought it was 36. Okay, good. 162√3. They don't give us units. We don't have to give them units. So 162√3 would be our final answer. Cool. Number 8, find the area of a regular hexagon with an apothem of 3√6. I'm going to save time, and I'm just going to draw that special triangle. There we go. We were given the apothem in a hexagon, not in an equilateral triangle, but in a hexagon, the apothem is across from the 60, meaning the apothem is our x√3. Now, we want to undo what's being done to x. We want to undo multiplying by √3. And the way you undo multiplying, the way to get rid of it, is to divide by √3. Well, this is cool. 6 is divisible by 3. They are both in the radical, so we are allowed to divide them. So x is 3√2. 6 divided by 3. I love how y'all follow along. Y'all are doing great. Okay, so where does x go? Here. And we don't even need to find the 2x because you don't use the radius in the formula for area. Okay, let's find the perimeter. 3√2 is not the side. 6√2 is the side, because this is half of a side. And then we have 6 sides. So the perimeter is 36√2. So apothem times perimeter divided by 2. I like to multiply through all of my whole numbers. For example, I like to do 3 times 36 divided by 2. So I used the 3, the 36, and the 2, and I got 54. And then I multiply my radicals. Square root 6 times square root 2 is square root 12. And unfortunately, we're not totally done. We have to factor tree because that is not a simplified radical. A 2 is going to escape. When the 2 joins the 54, 54 times 2, that's an 8. 108, and then a 3 is left over. So 108 root 3. Number 12, the first one that you've asked me that we're going to actually use trigonometry on. The apothem of a regular pentagon is 13. Find the area. All right. Good old trusty right triangle. I like finding that top angle. I think 360 divided by 10 is easier than n minus 2 times 180 divided by 2n. But as always, that decision is up to you. If I were to draw all of the triangles all over this pentagon, there would be 2 triangles per side. See, 1, 2. So if I take 360 degrees, and I want to know just that angle, I wouldn't divide it by 5 because it's a pentagon. I would divide it by 10 because there's 2 triangles per side. So I know this angle now. 360 divided by 10 is 36. I have tangent, which is what I usually have when I'm solving these problems because we have opposite and adjacent. Tan 36 equals x over 13. Then what Ms. Tanton taught you was to put your pencil down and spend the rest of the problem with your calculator, armed with the weapon of choice, which is your calculator. I don't want you to write any of your middle steps down because I want your answer to be exact. Okay, so multiply or divide. X is in the numerator, so we multiply 13 times tan 36, and we get a number. And that number is half of our side. So if you want to, you can double it, times 2. Now we have a side. It's pentagon, times 5. Now we have a perimeter. Times 13. Now we multiply it by our apothem, and then the formula says times 2, divided by 2, or times 1/2. So divided by 2. When you do all of those steps, you should get 613.93 or 613.9, depending on what you round to.